Welcome friends, let's answer this question. What constant makes e to the rx a solution of y prime minus y equals 0? So how do we think about this? Well, we're given a function e to the rx, and you're told a differential equation. So if you look at the left-hand side of the differential equation, it has two parts to it. There's y prime and there's negative y. All you can really do is just plug it in. So in other words, first find y prime. Now, it's true there are two letters. There's r and there is x, and you have to differentiate with respect to a variable. Which variable is it? So it's x as your variable. That means you have e to the rx like this. And notice x is with the deep here, with the dx, the differential. So by the chain rule, it's e to the rx and then derivative of rx. But the derivative of rx with respect to x as your variable. You treat the r like a constant. If you wanted to be very careful, you would have this in other words. E raised to the rx. Separate the r away, and then just differentiate the x alone. So that's going to leave you then e raised to the rx times r, since the derivative of x with respect to x is 1. So we have r e raised to the rx. Really, this is just an exercise in using the chain rule carefully. We already know what y is. It's e to the rx. So now we can just plug these into the left side. And so r e raised to the rx minus e raised to the rx is equal to 0. So all I'm doing is I'm replacing y prime with r e to the rx, and I'm replacing y with e to the rx. Now let's look at this. Notice that e to the rx is a common factor on the left side here, and specifically it's e to the rx times 1. Don't forget that. So e to the rx can be factored out because it's common. What's left then is r minus the remaining 1, and this has to be equal to 0. Now notice that here e to the rx, this is never equal to 0. Okay, maybe you don't know what that means, so let's see. Let me illustrate. Let me just make this smaller. Okay, I'm just going to choose some random arbitrary values of r, plug them in. I'm going to show something to you, okay? Imagine like I plug in r equals 1. What you have is a graph. This graph is always above the x-axis. It never reaches y equals 0. What if you plug in e raised to the negative 2x? So r is negative 2. Again, in this case, you have a graph that's always above the x-axis. It never is equal to 0. I know you may want to say it is equal to 0 right here, but that's not true. That's only a limitation of my graphing, and the fact that if I, for example, that I'm not zoomed in enough. If I zoomed in more, you would see that the graph and the x-axis do not actually touch. So e to the rx is never equal to 0 for that reason, regardless of the value of r you plug in. It's not true, which means the only way this can be true is if r minus 1 is equal to 0. But the only way that can be true is if r is equal to 1. Therefore, what makes this y prime minus y equal to 0, r equals 1. In other words, the function y of x equals e raised to the 1x, which is just x. And that's it. That's how you think about this kind of question. This is like a level 1 variant of this question. There are some more complicated ones with more terms, but that's enough for this one. Leave a like if it's helpful.